So welcome back again to my channel. By the way, I'm Gutierrez Donald A. And for today's video, I'm going to make a tutorial for chapter 5, which is entitled Mac Sublayer. So as shown in the figure, the Ethernet Mac Sublayer has two primary responsibilities: the data encapsulation and media access control. So the data encapsulation process includes the frame assembly before transmission. In frame, this assembly upon reception of a frame. So in forming the frame, the MAC layer adds a header and trailer to the network layer PDU. So data encapsulation provides three primary functions. The first is frame delimiting, addressing, and error detection. So frame delimiting is the framing process provides important delimiters that are used to identify a group of bits that make up a frame. So these delimiting bits provide synchronization between the transmitting and receiving nodes. So addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. So error detection, each frame contains a trailer used to detect any errors in transmission. So the use of frames aids in the transmission of bits as they are placed on the media and in the grouping of bits and the receiving node. So the media access control, the second responsibility of the MAC sublayer is media access control. So media access control is responsible for the placement of frames on the media and the removal of frames from the media. So as its name implies, it controls access to the media. This sublayer communicates directly with the physical layer. So underlying logical topology of Ethernet is a multi-access bus. Therefore, all nodes devices on a single network segment share the medium. Ethernet is a contention-based method of networking. So a contention-based method means that any device can try to transmit data across the shared medium whenever it has data to send. So the carrier sends multiple access collisions detection are called CSMA or CD. Process is used in half-duplex Ethernet LANs to detect and resolve collisions. So today's Ethernet LANs use full duplex switches which allow multiple devices to send and receive simultaneously with no collisions. So Ethernet evolution, since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. So this ability for Ethernet to improve over time is one of the main reasons it has become so popular. So early versions of the Ethernet were relatively slow at 10 Mbps. So the latest version of Ethernet operates at 10 gigabytes per second and faster. So scroll through the timeline in figure 1 to view the various versions of Ethernet. So at data link layer, the frame structure is nearly identical for all speeds of Ethernet. So the Ethernet frame structure adds header and trailers around the layer 3 PDU to encapsulate the message being sent as shown in figure 2. So Ethernet 2 is the Ethernet frame format used in TCP/IP networks. So let's move to the activity. So let's read first the instructions. So descriptions of the MAC and LLC sublayers are provided in the table. Click in the MAC or LLC fields to match descriptions to correct sublayer. So the first one that we have is controls the network interface card through software drivers. So it's LLC. Works with the upper layers to add application information for delivery of data to higher level protocols. So works with hardware to support bandwidth requirements and checks errors in the bits sent and received. So it's MAC. Control access to the media through signaling and physical media standards requirements is also MAC. So supports Ethernet technology by using CSMA CD or CSMA CA. So remains relatively independent of physical equipment at LLC. So you have successfully matched description to the correct sublayer. So that's all for today's video. I hope you understand and learn. So thank you for watching.